Welcome to the demo video of our IoT platform for heart failure patient monitoring. We developed a microservices approach platform in which services communicate among themselves through lightweight protocols and are independent from each other for what regards the development and the deployment. For this reason, each microservice and device has its own configuration file in which the information of the service or device are stored. All the users of the softwares, as well as the devices and the services that are part of the system, are registered in a catalog. This allows the discovery of the active services and devices. First of all, Telegram is the user interface of our platform. As mentioned before, the service registration to the catalog is the first communication of each service. Up front, cardiologists register themselves through Telegram. Each cardiologist will be registered on the catalog with unique identifiers. Our platform is built in order to allow scalability in terms of number of cardiologists, patients, and devices associated to the patients, as we will show in this demo. Once registered, the cardiologist can start adding new patients that will be part of the monitoring system. Each patient's health will be monitored using an ECG sensor and two other optional sensors, a blood pressure sensor and a blood saturation sensor. When adding a new patient, the cardiologist has to specify the unique identifier of the devices that will be given to the patient to monitor his health. The identifiers have to be unique among all the devices independently from the parameter they measure. As can be seen, for example, when a patient is associated with devices that have unique identifiers already present in the platform, Telegram gives back an error. Each patient, as for the cardiologists, will be registered on the catalog with unique identifiers. Moreover, each patient will contain the information of the associated cardiologist. Once the sensors have been associated to a patient, the devices are activated and are allowed to register onto the catalog. From this moment onwards, they will send periodical measurement through MQTT with personalized topics that include the measured parameter and the device ID. The patient's information can be updated at any time, for example, to add the identifier of one of the optional devices. Other updates that can be made are regarding the personal details and contact information of the cardiologist and of the patient under his care. The ECG recording as sent by the devices is analyzed by the signal processing microservice. This service is subscribed to all the topics that are published by the ECG devices. This software component removes any noise and trend and extracts characterizing features from the ECG signal. The features extracted are the distance between the RR peaks, the standard deviation of this distance, and the heart rate measurement, which is the inverse of the average of the RR distance. All these parameters are then published by the signal processing microservice through MQTT. The blood pressure and saturation measurements, as well as the ECG parameters computed by the signal processing microservice, are analyzed by the control strategy microservice. As can be seen from the terminal, the service is already present in the catalog at runtime. Therefore, it proceeds in sending a put request to update its info. Moreover, the error message refers to the fact that one of the services it should be in contact with is not up and running. Despite this, the microservice is functioning perfectly thanks to the autonomy property of this software architecture. Getting back to the control strategy service, this component compares the measurement with specific thresholds and publishes an alert through MQTT in case a parameter overcomes the above-mentioned thresholds. This alert is captured by the Telegram microservice, which sends a message to the cardiologist associated with the patient for which an anomalous measurement occurred. The message contains the information of the measurement that generated the alert so that the cardiologist can immediately take action if the patient's health is in danger by calling him or going to his house. All the measured data, processed parameters, and alerts are stored on InfluxDB, a third-party database for the Internet of Things. Each saved measurement contains the ID of the device that generated it, the ID of the patient to which the device belongs to, the presence of an alert, the measured parameter, and of course, the measure itself and the timestamp. The communication between our platform and the third-party software is allowed by an adapter, which gathers the data published via MQTT by the control strategy and the signal processing. The received data is then adapted to the correct format in order to be saved on the database. Moreover, this microservice exposes REST web services to handle the queries that are to be done to the third-party database. The queries have to be compiled with the time extremities of the request, the parameter requested, and the patient ID. On the Telegram bot, the cardiologist can also ask for a daily report of the patients in his care. This command starts the communication with the daily report microservice, which exploits REST web services to communicate with the InfluxDB adapter to gather the data of a patient in the last 24 hours. This service creates a PDF with the distribution diagrams of the patient's data and shares it via REST with the Telegram microservice. This document is then sent to the cardiologist on the Telegram chat. On Telegram, the cardiologist can also view the list of patients in his care and access the Node-RED dashboard for each of them. This service exploits HTTP REST protocol to communicate with the database to retrieve data and show it to the cardiologist. From this dashboard, the cardiologist can visualize the RR distance, the heart rate, the systolic and diastolic pressure, the blood saturation of the patient in the previous 4 hours. The cardiologist can easily adjust the time period of the shown measurement. If at any moment the patient does not want to be part of the monitoring system anymore, the cardiologist can delete him from the patient list. This will also cause the dissociation of the devices from the catalog. Finally, when a cardiologist wants to be deleted from the system, he can unsubscribe from Telegram. Only after all the patients under his care are either deleted or associated to another cardiologist.